Alright guys, now we have the next question in which we are supposed to prove that R is equal to 1 sigma n, R combination of 1 is equal to n plus 1 combination of 2. So we just need to prove that left hand side is equal to right hand side by the principle of mathematical induction. So we can follow the series of steps to get to the answer. So the first step is we'll try it for n is equal to 1. So when we will be substituting n is equal to 1 into the equation, so on the left hand side we get r is equal to 1 until 1, and we have r combination of 1, and over here I get 1 plus 1 combination of 2, right? So what I can write over here is it's 1 combination 1, which is 2 combination of 2. Now we know the formula of NCR or n combination r. This is given as n factorial divided by r factorial into n minus r factorial, right? So I will be applying this particular formula, which is 1 factorial, and in the denominator I get r factorial, which in this case is 1 factorial times of 1 minus 1 factorial, and on the right hand side I have 2 factorial divided by 2 factorial times of 2 minus 2 factorial, right? So this is what I get. Now if I simplify this, I end up getting 1 factorial divided by 1 factorial times of a 0 factorial, and on the right hand side I ended up getting 2 factorial and a 0 factorial. Now always remember that 0 factorial is always equal to a 1. So if we go by that analogy, so we'll get 1 on the left hand side and 1 on the right hand side. So because left hand side is exactly equal to the right hand side, so this means that for n is equal to 1, by principle of mathematical induction, the left hand side is equal to right hand side. So this property actually holds true. Now we'll just be trying for the second case, in which we will just be substituting all the values of n with that of k. Now we just go back into the equation, and wherever we find n, we'll just substitute that with k. So we have r is equal to 1 until k, and then we have r combination 1 on the left hand side, and on the right hand side we have that as n k plus 1 combination of 2, right? So this is what we get from this particular case. Alright, now what we already have done that, so this means that n is equal to k holds true as well. Now we'll go for the third step. By the way, I'll just be labeling that as an equation 1 because I have to utilize that result in the third step, right, in which I will be utilizing n is equal to k plus 1, right? So now I'll go back to the original equation, and wherever I have this n, I'll just be replacing that with the k plus 1. So if I go by that, it is given as sigma r is equal to 1 and k plus 1, and then I have that as r combination 1, right? And if I look into the next thing, this will become k plus 1 plus a 1 combination of, what was that? That's a combination of 2, right? Now what I will be doing over here is I will be just expanding this. So I need to look into this thing. What can I do with this one? So this becomes k plus 2 combination of 2, whereas I just need to modify my left hand side a bit, because I would be utilizing this particular result so that I can match the left hand side with the right hand side and can get my result. So I just need to make my left hand side look like the one on the equation 1, right? So the way I can do that is I can write that as sigma r is equal to 1 until k, and this becomes r combination of 1, and then I have that as sigma of 1 combination k plus 1. So now what I will be doing is I will be substituting this particular side which I have over here with the 1 in the equation 1. So this becomes k plus 1 combination of 2. So yeah, this is what I have, and this becomes k plus 1 combination of 1, and on the right hand side this is given as k plus 2 combination of 2. Now what I can do over here is I can just apply the formula and see if the left hand side is equal to right hand side. So if I apply the formula of n combination r which is given as n factorial divided by r factorial into n minus r factorial. So this becomes k plus 1 factorial times of a 2 factorial into k plus 1 minus a 2 factorial, and then plus k plus 1 factorial, I'll put that in the numerator, and then 1 factorial into k plus 1 minus a 1 factorial. Alright, so I would just be rubbing this bracket so that yes, it looks clean. Now on the right hand side I have that as k plus 2 factorial divided by k plus 2 minus a 2 factorial and then 2 factorial as well, right? So what I'll end up getting on the left hand side is it's k plus 1 factorial. Let's just simplify that. It becomes 2 factorial and k minus 1 factorial, and then k plus 1 factorial divided by a k factorial, and all of this is equal to the right hand side, which is given as this 2k factorial, right? That is what I'm left on the right hand side. Now what I can do over here is, for now I need to make the denominators as same. Now we just need to think about it, how can we make the denominators as same? So if I multiply k in the numerator and in the denominator, right? So I'm left with k plus 1 factorial, which is already there, and then 2 factorial into k minus 1 factorial, and then plus k plus 1 factorial divided by a k factorial, right? Whereas I already have proved what my right side is going to look like. So this becomes k times of k plus 1 factorial and divided by 2 factorial into k minus 1 factorial, and then plus k plus 1 factorial divided by a k factorial, right? Now sorry, we didn't write the k with this as well. Now if I look into this thing, this will become k factorial, right? So I ended up getting this as k times of k plus 1 factorial divided by 2 times of k factorial, and on this side I have this as, okay, what I can do is I can just multiply the two so that the denominators can be same. So I end up getting 2 times of k plus 1 factorial divided by a 2k factorial, right? So what I can do is I can take 2k factorial as the, because the denominator is same now, so I can just write them as a one single fraction, and then I'm left with k times of k plus 1 factorial plus 2 times of a k plus 1 factorial, right? Now is there anything that I can take common? Yes, I can do that, and this becomes k plus 1 factorial. Now if I look into this and this thing, I have k plus 1 factorial as common, so I'm left with k plus 2 and all of this divided by a 2k factorial. So now if I go back and the right hand side was k plus 2 factorial divided by a 2k factorial. Now is there a way I can make both the sides equal to each other? Yeah, I can do that, and this becomes k plus 2 factorial divided by a 2k factorial, which is equal to k plus 2 factorial divided by a 2k factorial. So yeah, because left hand side is equal to right hand side, so this means that by the principle of mathematical induction, n is equal to k plus 1 is true as well, right? So at the end you will just be writing the final statement, and that final statement is because n is equal to 1 is true, right? And n is equal to k is true as well, and n is equal to k plus 1 is true by the principle of mathematical induction. So this means that over here initially we were provided with this thing, n sigma r is equal to 1 till n, r combination 1 is equal to n plus 1 combination of 2. So yeah, that is how you will prove this thing. So you just need to write the original equation that was provided to you in the question booklet. You just need to write that over here, and that is going to be your final answers, and that is how you'll get the marks.